Well, welcome. We just want to look at the equation of a plane, okay? And already you have looked at vector equation and you want to look at equation of a plane. Remember here we are dealing with three-dimensional, not two-dimensional. So first of all, let's try to prove the formula for the equation of a plane. So for you to start that, you will need this three, where we know that here is x, here is z, and here is y. Let's assume that I have a plane here. This is a plane, okay? And I have a line that comes to this plane, and that line is called normal. A normal line is a line that is a perpendicular to the plane. Is that okay? It is also called orthogonal, okay? So this one can also be called orthogonal. Orthogonal. So orthogonal means perpendicular or normal. Is that okay? Now let's say that I have this point here as point P naught, okay? And I have another point here, also on the plane, as point P. Let me name here as the origin. Now from the origin to the point P, let me name it R. And from the origin to point P naught, let me name it R naught. Is that okay? If I join this one together, let me name that one vector A. And this vector R, then vector R naught. Is that okay? So this is what we have. Now with this one, if I want to use the triangular law of vector, you see O, P, P naught is a triangle. So I can use triangular law of vector to find vector A. You know that from the triangular law of vector, vector R should be equal to vector R naught plus vector A. So vector, all right, let me do something here. Let me group like I'm making vector A the subject. So if I make vector E the subject, I'm going to have vector R minus vector R naught. Is that okay? So in place of vector A, I can put vector what? R naught there. Also, if I finish with this, once this normal here is orthogonal to the plane or to the line A, then we can say that their dot products is equals to 0. So the dot product of orthogonal or a normal line to the plane is always equals to 0. So in this case, our A here, we know it to be R minus, okay, let me bring the n first. We know it to be R minus R dot, right? And this is equals to 0. So in this case, I can have n dot R minus n dot R naught equals to 0. This, either this or that, is this one is a simplify of this. It's called equation of a plane. Is that okay? So this and that, they are the same, just that this is a simplified form of this. So this one is called vector equation of a plane. So this is called a vector equation of a plane. Is that okay? So anytime they ask you to find a vector equation of a plane, you can use this formula to do that. Now let's also look at scalar equation of a plane. How do you get a scalar equation of a plane? Remember that anytime you dot two vectors, the answer becomes the scalar, or becomes the scalar, or right? The answer you get will be a scalar. That's what I'm trying to say. So when you dot two vectors, the answer should be a scalar. So in this case, I'm going to dot this. So if I'm to dot this, what happens here is that if I let my r for the n, the normal vector is just numbers, okay? So I can represent that one by A, B, C. Is that okay? My r, that is a point. So I have to be X, Y, Z. This is the r. The point of it is here. And then r naught should also be X naught, Y naught, Z naught. Because it's also a point on the plane. Is that okay? So if I just do substitution here, let me bring it here. I'm going to do the substitution here. You realize that my n here is A, B, C dot. Anytime you're writing a vector, it should be like this, okay? That's why I'm using this, not the normal parentheses, you know. And this is X, Y, Z minus. In this case here, I'm going to repeat my A, B, C dot X naught. Remember here is supposed to be R naught, Y naught, and Z naught. Right, and this is equals to 0. So let me try to expand this one. Because it's at the outcome of a dot product is a scalar. I'm going to have this times this is AX plus B times Y is BY plus CZ minus. So this one is actually in bracket. Let me put it in bracket because of the negative affecting everything. So I'm going to have AX naught plus BY naught plus CZ naught. And this equals to 0. Remember, when you are dotting, is this times this, then B times the Y, the C times the Z, and they are the not there. Let me group like terms. This AX minus AX naught. So I can bring it together. AX minus AX naught. Where from the minus, because of this minus, it's affecting everything there, right? Plus, if I take BY to be minus BY naught, plus if I take CZ, it will be minus CZ naught. And this gives us 0. Is that okay? Hope at this point you are not confused. Now A and A is common. So if I bring A out, I have X minus X naught plus B, Y minus Y naught plus, all right, C, Z minus Z naught equals 0. So this is a very beautiful thing, right? So this is what we have. Now, after getting this formula is called the scalar product. Is that okay? After having this formula is called scalar equation of a plane. Scalar equation of a plane. Is that okay? So this is a scalar equation of a plane. And this is called a vector equation of a plane from here. So these are the two things. But this particular formula, we can do something about it by sending the one with the Y naught, Z naught, and the Y naught, X naught to one place. I think I've made a mistake. This is BY naught. So here's supposed to be, I think here, starting from here. So please let me correct this. Oh, it's not a mistake. AX goes with this, right? BY goes with BY naught, excuse me. Then CZ goes with CZ not a CZ. Okay. All right. So I think that is it. There wasn't any mistake there. So this is what we have. Now, I believe that here we are okay. So let me show you something small here. From this particular point, I can decide to send the whole of this one to this place because these are just numbers. But here the x, y, z, they are variables, which is in terms of x, y, and z. But a, b, c are numbers, x naught, y naught, z naught are numbers. So in this case, I can send all of them to this place. So what I'm going to get here is if I do that, I'm going to have ax plus by plus cz equals ax naught plus by naught plus cz naught, right? Now we can say that let's d to be equals to ax naught by naught cz naught. So means that wherever I see this one, I can replace by d. So equals to d. This one too is called a scalar equation of a plane, this one. So you can decide to use this formula or this formula. They'll all give you the same answer. Remember that the d is ax naught plus by naught plus cz naught. Thank you. Now let's see how we can solve questions under this. Now let's see how we can solve question under this in my next video. Okay, yes, in my next video. So stay tuned.